Hi everybody, it's Mrs. Mancuso. Merm. Here is your next video on acids and bases. So this is a little bit different. It's not Arrhenius acids and bases. So it's not your typical, like the base would be a metal with an OH minus. Instead, these are sort of weird. Sometimes water could be an acid or water could be a base based on how it behaves. If it gives up an H plus, it's an H plus donor, so it's an acid. If it accepts or takes an H plus away from a solution, it's going to be a base. So here's my little definition and how you do it. You have to look at the reactants and compare them to the products. See what's happening, what's changing between them. The reactant that gives away an H plus, that's an H plus donor. So that's your acid. The one that accepts it, that is going to be your base. So let's do it together and see if you understand what I mean. So I'm going to look at HSO4, HSO4 minus, and then over here on this side of the arrow, it becomes SO4 minus 2. So it has lost an H plus. So the one that loses or donates the H plus is my acid. So that's my acid. And then now I'm going to look at water. And so water becomes H3O, so it gains it. So this H is going from here to here. So the H plus is what's represented by my arrow, and I can't have it cross my arrow of my reaction. I can only look at my reactants right now. So I can only look at the two things on the left side. The H plus goes from here to here. So this is going to be accepting it. So it's my base. And if I look now on the other side of the arrow, I see that this is the one that has lost its H, and this is the one that has accepted an H. So that's why it was the acid and the base. Now I want to do the reverse reaction. So if I look in this direction, this SO4 minus 2 has to gain an H. So the H is going to be donated from here, and it's going to be gained here. So wherever the arrow starts, that's my acid because it's giving away the H plus. And wherever the arrow ends, that's my base because it's accepting the H plus. So if my multiple choice question gave me this reaction and it said, name the two acids, I would have to do the arrows and I would say, all right, this is one of the acids. This is the other acid. So it would be HSO4 minus and H3O plus, because in this overall reaction, forward and reverse, they are the ones that gave away the H pluses. All right, I'm going to move on to another one, and I suggest throughout this video that you pause it, you try doing it yourself, and then play the video and see if you did it the same way I did. So I'm going to start with HCl, and I'm going to notice that it loses an H plus. So it's going to give the H plus to here. So where I start is my acid, where I go to is my base. And now if I do the reverse reaction, the H3O minus gives the H plus to the Cl. So since it was giving it, it's the acid, and since it was gaining it, it's the base. So my acids are HCl and H3O minus. There's my two acids. All right, next one. Get a different color here. HPO4 minus 2 becomes H2PO4. Ooh, it's getting an H plus. So my H has to go this way in order for it to gain an H plus. So this must be my acid because it's giving it away, and this is gaining it, so it's my base. And now I do the reverse reaction, and H2PO4 is going to give an H to this to make it water. So this is the donator, and this is the acceptor. Next one, NH4 becomes NH3. So that means it's going to lose an H plus. So I go like this and I show it giving it away. And so this is my acid and this is my base. And if instead I do the reverse reaction, HCO3, this H is going to go to here. So this is my acid and this is my base. It doesn't always work out that it goes A, B, B, A. You just have to figure out where the arrows are going in order to do it. All right, next one. HCOOH becomes HCOO, so it loses this H. So this is my acid and this is my base. Oops, base, ugly B. All right, and then over here, this H is going to go to here. So this is my acid and this is my base. And one more of them as one more practice for you. NH4 becomes NH3. So this is going to donate. So this is my acid and this is my base. And then one of these H's is going to go to here. So this is my acid and this is my base. All right. There's a whole nother practice sheet for you to do just to make sure that you understand how to do these problems. And there's also some multiple choice, just so you see how you do it in a multiple choice question. All right. Next thing I want to do with you is writing neutralization reactions. So if you are neutralizing, you are taking an acid plus a base, and you're going to make a salt and you're going to make water. So those are what your products always are. So the H and the OH are going to come together. So one of your products is H2O. And then the Na and the Cl are going to come together. Na is a +1, Cl is a -1. So my other product is NaCl. So that's a neutralization reaction. Often on a part 2, they have you write out the products. So let's do a couple more together. Let's say I have H2SO4, that's my acid, and I have NaOH, that's sodium hydroxide, that's my base. So my H and my OH come together, so that's H2O. And then now I got to put my Na, which is a +1, with my SO4, which is a -2. I know that because the 2 crisscross down to the H from it, and I could look it up on table E. So this is a -2. When I cross that, I get Na2SO4. And then to balance it, I need 2 NAs, so I'm going to need 2 of those. And I have 4 H's, so I would need 2 waters. So now it's balanced. I'll do a couple more of these with you. I'm going to look at table K just to give me some ideas. H2SO3 plus CaOH2. All right, my H and my OH come together, so that's water. And then my Ca and my SO3. Ca is a +2. SO3 is a -2. Again, I know that because that 2 came from up there, and I could look on table E and it tells me SO3 is a -2. So if I crisscross those, they cancel out. So CaSO3. In order to balance it, to get 1, 2, 3, 4 H's, I would need 2 waters there. All right, let's do another one. CH3COOH. That's actually vinegar. That's acetic acid. If I put that together with, let's say, KOH. All right. This H and this OH are going to come together, so that's H2O. Sort of looks a little weird because it donates the H plus off the end, but CH3COO is a -1. So this is all a -1, and this was a +1. K is a +1. OH is a -1. So my other product, the K, is going to go with the K is a +1. CH3COO is a -1. So I put it together and I get KCH3COO. All right, let's do another one. Let's do HNO2 plus MgOH2. All right, my H and my OH come together. That gives me water. And then my Mg with my NO3, Mg is a +2, NO3 is a -1. So I would get Mg parentheses NO3, 2 of them. All right, so that's how you go through and you, oh, wait. 1, 2. I got to balance this. 2 NO3s. So I'm going to need a 2 here. That gives me 4 H's, so I'm going to need 2 waters. Okay, always remember to go back and balance your reactions. So that's the end of this video. Make sure that you go through and you do the practice that goes along with this. And then the next one, we'll be doing the calculations where we're calculating these neutralization reactions. So if I take an acid and I take a base, I could actually figure out based on their volumes and one of their molarities, what the molarity of the other one was. All right, so hope you guys are doing well, and I will talk to you soon.